Hi guys, how are you all doing? And it's Jalal Aura here again, back from BHM at GCSE Chem. And today we're going to be doing C2.2, which is the electronic structures and the periodic table. So electronic structures and the periodic table. So yep, this is the book. So GCSE Chemistry Revision Guide. And as I said, today we're doing C2.2, which is the electronic structures and the periodic table, so that's what it's called. And yeah, from the last section, obviously, well, what I'm going to be doing now is when we go through a question in this revision guide, I will be basically, when they give us the questions, I will be checking my answers just in case. From now on, chapter 1, when I checked them as well, and they were all right, so I didn't have to check them. But this one, I'm going to be very careful about saying my answer, then checking, making sure it's correct. And I'll be doing this for all of my videos, or this video and all the forthcoming videos as well, just to make sure I'm getting the right terminology, and so that I can give you the exact kind of answer. The mark scheme kind of answer, not the marks, but the answers, because there are answers in this book, so it'll be good to know the actual answers, and they'll be very similar to obviously what I say, but yeah, just to be exact, that's what I'll be doing. And so today we're going to be doing electronic structures and the periodic table, which is C2.2. If you're following the it's not coming out of my, the word's not coming out of my mouth today. If you're following the student book, which is the big book, it's pages 24 to 25. There we go, finally. And this stuff, it's very related to C1.8 electronic structures, and it's really cool because it's very much related to that. It shouldn't be too hard. It's quite basic. So yeah, let's start. So the elements are arranged in the periodic table in order of their atomic numbers, which are proton numbers. The elements are arranged in groups, which are vertical columns with similar properties. So, elements are arranged in groups, so elements in the same group have similar properties, basically. And, so the elements are arranged in groups, which are the vertical columns. I think I showed this in my first video as well. The vertical columns are the groups, the horizontal rows are the periods. And that's a good way to remember that the vertical columns are the groups and the horizontal rows are the periods. This action and then this action. So, yeah. So, and by the way, nowadays we arrange the periodic table is arranged, in order of atomic number, or proton number. But before, this is linking C2.1, which is development of the periodic table. When it was first developed, it was based on atomic weight or mass number, but nowadays we use atomic number, just for your reference. Excuse me. The groups of elements have similar chemical properties because their atoms have the same number of electrons in their highest occupied energy level, which is outer shell. So, yeah, elements in the same group have similar chemical properties because they have the same number of electrons in their outer energy level, or outer shell, basically. So that's important. And again, that's very related to C1.8. In fact, I think we did go over this in C1.8 as well. So it's very much interlinked. This section is with C1.8, so 2.2, C2.2, very interlinked with C1.8. So now the group number equals the number of electrons in the outer shell of an atom. So that's the next bullet point. And we know that, so the group number tells us the number of electrons in the outer shell of that element or outer energy level. Like group 1 elements have 1 electron in their outer shell or outer energy level. Group 2 elements have 2 electrons in their outer shell or outer energy level. And it's also called valence shell, by the way, you can call it. But yeah, that's basically that trend keeps going on. And here's a question: why do elements in the same group have similar chemical properties? Well, the answer is that the answer for this is that it's because they have the same number of electrons in the outer shell. So that's basically the answer for that. And then I'll just see. Just trying to give you the exact wording from now on for it. for each of these questions, because yeah, even though I know I'm right, I just want to kind of give the exact wording. So the wording in the book is they have the same number of electrons in the highest occupied energy level or outer shell. So that's basically what I said. So they have the same. Sorry. So what did I say? The answer is they have the same number of electrons in the highest occupied energy level or outer shell. Yeah, that's what I said. So elements in the same group. Why do elements in the same group have in a group of similar chemical properties? Because they have the same number of electrons in the outer shell or outer energy level, in the highest energy level or shell. I think that's what I said. Pretty sure that's what I said. But yeah, most elements are found on the left-hand side of the and the center of the periodic table. Metal elements tend to lose electrons and form positive ions. Yeah. So most elements are found. Metal elements. Sorry, no. Let me read that again. Metal elements are found on the left-hand side of the periodic table, and they tend to lose electrons. So these metal elements tend to lose electrons to form positive ions, which are also known as cations, by the way. So we know that now. Non-metal elements are found on the right-hand side of the periodic table, well, right-hand side, and towards the top of the periodic table. Non-metal elements tend to gain electrons and form negative ions. And once again, just for your reference, this is also known as negative ions, also known as anions. Now, next bullet point is obviously the atoms of noble gases in group. The atoms of noble gases in group 0 or group 8 as well. They are known as. Are unreactive, and this is because they're stable electronic arrangements. They have 8 electrons in their outermost shell or energy level, except for helium, which has just 2 electrons. But this complete first shell is also very stable. Is also a very stable electronic structure. So in group 8 or group 0, normally it's called group 0, but can also be referred to as group 8. They're the noble gases. They're very unreactive, and the reason for that is because they have stable electronic arrangements or stable electron arrangements, and all of these elements apart from helium have 8 electrons in their outer shell, so again fitting that trend. So they're in group 8 because they have 8 electrons in their outer shell, and the only exception is helium because that only has 2 electrons. So that but it's those 2 electrons still completely fill up the first shell, making it very stable, and unreactive element. Yeah. And that's why helium's also used, in helium gas is used in balloons as well, because it's obviously very unreactive, so not very harmful. But yeah. So here we have the periodic table, the most fundamental thing in chemistry, really. And I'll just read these things out that it says here. Here it says, the reactive metals, which are on the left-hand side of the periodic table, these metals react vigorously with other elements like oxygen and chlorine, and with water. They're relatively soft. Some of these elements can even be cut with a knife. So these are basically groups 1 and group 2, very reactive metals. And then you have the transition elements, also known as the transition metals, you can call them, because they are metals. They're this section. The reactive metals are groups 1 and 2, basically, and then the transition elements are this section, this yellow section there. And this block contains the elements that most people think of when they think of the word metal, like iron, copper, silver, and gold. These metals are usually very reactive. Some, like silver and gold, are very unreactive. Not all of these are very reactive. Some, like silver and gold, are also very unreactive. And then here you have the noble gases. Oh, by the way, here you have the non-metals. These, these elements generally have low melting and boiling points. So you can see here. So if I can just show you properly. These are the not. Sorry if you can't see that, but these are the non-metals basically. Yeah, and these have very low boiling points and melting points and boiling points. And then finally you have group 0 or group 8 as well. That is called, and these ones, the purple one is the noble gases there. The orange ones were the kind of non-metals. The orange kind of ones there. So noble gases are also non-metals, and they're very unreactive, and it's very difficult to get them to combine with other elements. They're very, very unreactive. That's the main thing there. And then here's a synoptic link. Oh wait, I forgot. I missed a question, which was actually why are noble gases so unreactive? The second question. Sorry about that. The answer is obviously because they have stable electronic, or electron arrangements, because they have completely filled outer shells. So that should be the answer. I'll just check again to give you the exact answer, but it's basically around that. That's basically what I would say. And it's because they have very stable electron arrangements, and they have complete outer shells or energy levels. Yeah, basically they have their shells are completely filled. They have complete outer shells or completely filled energy levels. Outer energy levels. So that's fine. And then the key points for this section, just to finish off. Wait 1 minute. Yeah, synoptic link. I don't know if I mentioned this before, but topic C1.7 explains how atoms can lose or gain. Topic C1.7 explains how atoms can gain or lose electrons to form ions. Yeah, we saw that in C1.7, and we saw that metal atoms lose electrons to form positive ions. Non-metal atoms gain electrons to form negative ions. Positive ions, positive ions are also known as cations, and negative ions are also known as anions. So basically, metal ions are cations, non-metal ions are generally anions. So basically, that's it. And then key points just to finish off. So the atomic or proton number of an element determines its position in the periodic table, because obviously periodic table, the elements are arranged in terms of their, in terms of atomic number, in terms of increasing atomic number. By the way, that's how they're positioned. The number of electrons in the outermost shell. So this is the second point. Number of electrons in the outermost shell, or the highest energy level of an atom, determines its chemical properties. Yeah. That's very important. Number of electrons in the outer shell or highest energy level determines its chemical properties. I think it's very important to say chemical properties, because the chemical properties are the ones that are similar for elements in the same group. Now, the third bullet point is obviously the group number in the periodic table equals the number of electrons in the outermost shell, and I think that's a really, really important point to remember. They might ask a question about this, and it just says, the group number tells you the number of electrons that there are in the outermost shell. So they might, they might ask a question on this, basically, like say, why is they might ask why, for example, lithium and sodium react in a similar way. All you have to say is because they have, they both have one electron in the outermost shell or outermost energy level, and therefore they're in group 1 as well. So they react chemically in the same way. So and they have similar chemical properties, or same chemical property. Similar is better. But also the fourth point is the atoms of metals tend to lose electrons, whereas those of non-metals tend to gain electrons. I talked about that before as well. And then the final point, just to finish off, is the noble gases. So the noble gases in group 0, or group 8 as well, you could say, is very, it's more common to say group 0 than group 8, but, it's also called group 8 as well, just to let you know there. The noble gases in group 0 are unreactive because they're because of their very stable electron arrangements. So that's all for today. That's the end of C2.2, which was, what was it called again? I forgot. There we go, electronic structures and the periodic table. So very, very similar to the stuff we did on C1.8, which was just about electronic structures, just key ideas from there being pretty much recapped in C2.2. But these are very, very important ideas to actually get inside your head. And as I said, I hope this was really helpful. Make sure to share, like, and subscribe. And if you haven't already, also make sure to turn that notification bell on, so that you are updated when you're notified when I upload new videos that you can watch, which I try to do every day, and so far I have been able to. And hopefully in the future I can as well, every day. So that you're just, you're kind of updated, when I'm uploading new videos that you can watch. So that's all for me to say. Again, I hope it was a really useful video, and I'll see you tomorrow for C2.3, which is a very interesting one actually. It's on group 1, the alkali metals. Until then, bye. Enjoy the day. Thank you very much, guys.